Hello everyone, we are the Team 4. The building consists of large spherical interlocking discs with different diameter and curvature. Some discs are horizontal and are located at the top of others. The vertical disc from the spot of the building and transfers the horizontal load to the bottom. It consists of interconnected discs, like internal and external discs. The building enclosure consists mainly of hyperbolic FRC panels. These panels are mounted on adjustable secondary steel structures. These secondary structures are located sequentially in a bottom structure made of tiered metal plates, with foam glazing attached to the entire surface. On a roof sealed with insulation and asphalt roof. The connection between the primary and secondary steel structure supporting the sandwich is secured with bolts. These screws control the geometry of the convert lens and feature an internal circular line. The support structure consists of steel structures called primary steel structures. The panel is attached to the secondary structure source built-in components using a three-dimensional, adjustable fixed structure specially developed by the WSS. The WSS creates of 3D BMM by aligning the location of this attachment point with the substructure. The FRC panels receive stainless steel internal parts and welded bolts with retaining bolts at the prefined joint. Depending on the mounting location or type of panels, these so-called fasteners have been developed as a point nose panels for use with normal cuts and disc edges. After panels alignment and finement, seal the joint with a permanently elastic, thinly sprinkled with sand. Figure 4 shows the impressions of construction process. Some images convey a sense of the enormous size and geometric complexity of the project, which is a special challenge of everyone involved. Werner Sobek-Sturger performed a full 3D plan of the all metals components in the base steel structure. The goal is to develop a very different interface and geometry instruction into a continuous and optimized substructure. The latest parameter 3D design. Two and highly specialized planning teams can manage vast amount of data, including ongoing BIM design, coordination, and make timely use of quality and the precision you need. The structural design of the tender was carried out by a rule-based of the tackler software system to rationalize the main steel structure. The standardized transport structure system was designed to provide radial alignment for larger transfers, roof discs of a single alignment of supports and beam of smaller vertical discs. Due to similar random geometry arrangements, individual disc segments are often superimposed. Therefore, in order to accurately record the entire load transfer, a large fraction of the model must be fully calculated. The structure of the building includes a number of instructing steel frame disks, thus creating many connections between disks of different geometry shapes. External steel manufacturers and their design team worldwide to create as effective a regularization solution as possible. Although many customized connections are unavailable, a significant number of connecting CHSS can accommodate a large number of incoming member areas, thus standardized supporting steel areas, to communicate the information to the contractor. A number of connections have been designed and detailed on drawing with 3D, perspective, and 2D sections. The property of each connection point are important because it is impossible to actually understand geometry and design without caption of a three-dimensional intersection. Within a disk, connections are defined as typical arrangements, such as sports connection to truss cord. It's simpler than disk-to-disk connection, but it's also useful to understand in 3D how subtle geometry change between disks change the nature of the connection. Typical internal connections are replaced again by 3D and 2D information on the drawing, including a parameter table, such as plane thickness and the bolt number defined for different concentration, dimensions, and angle of incoming member.